This is one case-based questions based on similar triangle. It says Ramesh places a mirror. This is the mirror placed here, and to determine the height of the pole, he stands at a certain distance so that he can see the top of this pole being reflected on the mirror. Ramesh's eyes, that means this height, the height at which the Ramesh is, eyes is placed from the ground is 1.5 meter. The distance between Ramesh and pole, that means this distance, you can say, yes, this distance is given as 1.5, and this is, yeah, 6 meter. Now, in the first part, we have to find the condition of similarity. So let's say if I draw another figure, we have this as the height of the pole. This be the height of Ramesh. Let's say this is the place where mirror is placed. Right. We know that anything which is standing vertically on the ground makes an angle of 90 degree with the ground. So these two angles are 90 degree. Now, if I name this triangle as A, B, C is the point of mirror. Say this is D and this is a M. We are given the height of Ramesh is 1.5 meter. This is 1.5. And he is standing at a distance of 1.8 from the mirror. And the pole is at a distance of 6 meter. In the first part, we are asked the condition of similarity. So what you can see here that one angle is 90 degree here. Now, in order to prove the second part, we have to use the concept of reflection that we have studied in chapter light. So, right. Let's say if I draw a normal here, the normal which is perpendicular to the reflecting surface. Since C is the reflecting surface, C is the reflecting surface. So this is normal which is an angle of a line which is perpendicular to the surface. So we know that this angle is 90 degree. Second. The first thing, the angle of incident is the ray of light coming from here is striking the mirror over here. So we can say that this being the angle of incidence and this is the angle of reflection here. Now this whole angle is 90 degree. So I'm marking this as angle 1 and angle 2. What you can see from the figure that angle 1 plus I, that is the angle of incidence, is equal to angle 2 plus angle R. R being the angle of reflection here. As I said, normal is something which is standing perpendicular to the reflecting surface. We know that angle of incidence is equal to angle of reflection. Therefore, we conclude that angle 1 is equal to angle 2. So from the figure, you can find out that this angle is equal to this angle. This is what we have proved here. This angle is equal to this angle. So once these two angles are equal, we can also see that these are equal. So from angle, we can say the triangles are similar. So the two angles proved is one is this is equal to this, and the second is this angle is equal to this angle. Now that's the first part. Then we have to find in the next part is to find the height of the pole. So let's say if I take, this is what the height of the pole we have to find out. Once we have proved the triangles, these two angles equal, we can say the triangles are similar. That is ABC is similar to triangle MDC. Now two triangles are similar, then we can write their sides as proportional. So the first two letters, say AB corresponds to MD. So AB over MD is equal to BC, which corresponds to DC. So that is DC. AB is what we have to get. So let it be as it is. MD, the length of MD is given in the figure, which is 1.5. BC, which is mentioned as 6. And this is 1.8. Now, in order to get AB, I'll transpose in order to get the length of AB. This is 6 over 1.8 multiplied by 1.5. Transposing this to the other side. This is 1.5. Now we have equal decimal in the numerator and denominator, so we can remove it. 6 one time and 6 3 times 18, 3 one times and 3 5 times. So we got the length of AB as 5 meter. So this is what we have to find out, the height of the pole, and that is 5 meter. This one is 5 meter. The next is if the angle of incidence is I, then tan I. Okay, that means we have to get tan I. Tan I, tan theta is equal to perpendicular upon base. Now, for that, you have to consider the triangle first. Let me shed the triangle. I'm talking about this triangle. Here is this one. So we have to find tan I, right? That's what tan I. That means we have to get this angle, this angle first. Now, what is the value of this? Now, since this angle, whatever this angle, should be equal to this angle A, right? By alternate interior angle. So whatever is this angle is equal to this angle. Now, tan I, if I use tan I, I'll write it here. Tan I, which is, as I said, this is same angle, which is tan is perpendicular upon base. Perpendicular is what? The side opposite to 90 degree. That is, sorry, side opposite to the angle considered. So perpendicular is 6 and the base is 5. So this is 6 by 5 should be the value of tan I. This is 6 over 5. Now, the last part, there's an or part also. He said, now if Ramesh move behind such that the distance between the pole and the Ramesh is 13 meters, and he place the mirror between him to see the reflection of the light in right position. So what is the distance between the mirror and Ramesh? Now we have to make another figure, but keeping in mind that we have to shift the position of Ramesh. So the distance, so that the distance changes to how much? What's the new distance? Let me show you. So the new distance between them is 13 meters. So I can take, so this as x. So this is going to be 13 minus x because the total distance is given here. Now I can make some space here first. This we have done. Make space. So using the same concept of ratio, we can we know AB which is 5 and MD which is 1.5, BC which is according to the question is 13 minus x, and DC which is x. So this on reducing become 10 over 3. Now by cross multiplication, it says 10x is equal to 13 into 3 multiplied by this is 39. 39 minus 3x. So if I transpose this to the left hand side, this is going to be 13x is equal to 39. So x turns out to be 39 by 3, which is 39 by 13, which is 3. So we'll say that the x is equal to 3. That is what they have to determine in this. What is the distance between the mirror and Ramesh, which is 3 meters in this case.